Seeing as it's all quiet and you're all here, I figure we better get started. So to kick off, my name's Max Carlis. My background is I spent a few years in the innovation labs at Lloyds Banking Group before doing independent consulting, and I now work for Start Design as a strategist, where we have Barclays as a large client. So that's how I'm engaged in the fintech space. So this event is from We Are Fintech. So there's a hashtag. We Are Fintech, and Z, who's at the back here, I'd like to point out, is the person who's made all this possible. If you want to thank someone at the end of it or during it. So We Are Fintech, obviously together with SAS, who have been a massive support in driving this. The aim of today is we're going to try and get from the experts exactly what all of you have come here to find out. So if you don't have questions already in your head, please do think of some. There will be time for Q&A. Ultimately, it's my job to make sure you go away from here smarter than when you arrived. I like to think you'll have at least 3 good facts or case studies or examples or contacts out of tonight that you can take forward and think it was worth not going home straight after work today. If you're not getting that, let us know. We want to make sure you do. And I think that's really good value for anyone who's got 3 stuff that sticks with you, and a week later they're still of use to you. So I think that's where the bar's set. Let us know if we're not meeting it. The format of tonight is we've got 2 speakers who are going to do a presentation about AI, starting off with the short term and then looking at the longer term. We're then going to run a panel with, I think, 5 speakers, and that'll be a chance where I'll kick off with a few questions, but we really want you to come in and make sure your questions are there too. Okay, so kick off. Can we have a round of applause for John, who's going to give us our first talk tonight?
Hi everyone, my name's John Spooner. I head up analytics for SAS UK and Ireland. But really what I want to do today, just for 10-15 minutes, is talk around basically AI and start to dispel some of the myths and hype that is currently going on in the marketplace and in a lot of organisations at the current time point. AI is a topic area that both Noah and I could talk about probably for many hours, but we're just going to literally touch the surface, and I'm going to look at, well, where are we at the current time point with regards to AI, and then I'm going to hand over to Noah, who will give you more of a longer term view of where we're actually going and the journey that we're going on. So if we think about what is actually AI, the big problem that we've got with artificial intelligence, as soon as people refer to that word of AI, this is the image that gets conjured up in the minds of people within organisations. And it's also an image that's also starting to be created is it's the magic bullet for any problem that an organisation may have. I need to do something, AI therefore is the answer to that. But what actually is reality, and what are we actually trying to do when it comes to AI? And really I see it as you're trying to do one of 2 things with artificial intelligence. You're either trying to build a system that can basically perform something, a human task in some sort of way, in a clever computerized way, or we're trying to build up systems that think on a par with a human. The definitions that I see here is really what we've got is weak AI and strong AI. And where we are as society is very much in that first definition, where we're creating systems that are very good at doing one specific thing. So there's a lot of hype around self-driving cars and computers that can play chess incredibly well, play Go incredibly well, but they're very good at doing one specific thing. But can you take that AI application that was built to be a grandmaster of chess and use it to drive a automatically driving car? No, you can't. Can you then take the algorithms that are designed specifically to drive a car and get that same system to outperform a grandmaster at Go? No, you can't. So what we actually have is the ability to create what seems to be artificial intelligence, but it's more weak AI. Specialists at doing one thing. Very good at doing that, but we're not currently at the stage, and Noah will talk about it in more detail in a minute, we're not at a stage where we are building systems that can physically think like a human. And a lot of the hype around artificial intelligence gives the impression that this thing is new and we're going into a revolution. Well, actually, AI is more of an evolution than a revolution. We're going through that process more quickly than we have done in previous years, but we're still evolving. And I really see we're evolving in 3 different dimensions. We're evolving in terms of the intelligence that we've got about data and what drives a particular process. So we're getting more data that we can make decisions upon. The more data that we can make decisions upon, then the more accurate those decisions can be. But the data itself doesn't deliver any value. It's the modelling that sits on top of that data that creates some value, picking out the patterns and trends that are within that data. And we're becoming more intelligent with the type of modelling that we're doing. And then where we're getting to is building systems that then allow us to interact with that system in a more human-like way. So let me just expand on some of those areas. If we think about data, well, I think a statistic that I last heard was 90% of the world's data has been generated in the last 18 months. We are now at a point where we have the technology to analyse a lot more data and a lot more granular information we can now capture about a process or processes. So we can take our traditional structured data and analyse structured data in a lot more detail and do a lot more summarisations on our data. We can deal with unstructured data, whether that's text, whether that's conversations over the web or call centres. But now we're in that realm where we can also start to get some insight from unstructured data such as audio or images and videos. We're creating that more granular data, and then as we get into the Internet of Things, we're now producing a lot more data about a particular process. And that's where these systems that we're developing are being seen as more intelligent because we've got more data about a process. But we're also becoming more intelligent with regards to the modelling of that data. So really what a lot of the talk within artificial intelligence is around the topic of machine learning. But a lot of people look at machine learning and just look at the algorithms themselves that drive machine learning. So looking at decision trees, neural networks, gradient boosting models, there's a whole range of different machine learning algorithms that are available. But as we move through time, those algorithms are getting more and more complicated. So it's a case of, have we got environments in place that can run those algorithms at scale? So at scale, I mean at the amount of data that you're pushing through them and the sophistication of that data, but also at scale in terms of the speed that they can run. But what we want to do is to start to build up systems that is starting to automate the process of building those models and then deploying those models as well. At the end of the day, when it comes to machine learning, what we're doing is putting inputs into a model that then is going to deliver an output and deliver a decision. So we may have images, your structured data that's all going into an analytical algorithm that's then producing maybe the likelihood of a transaction to be fraudulent, or the likelihood of a customer to default on a loan, or the likelihood of a picture to a likelihood of an image to have a picture of a bird within there. It's a model that's being trained up on that data that's being put into it. The reason that we're becoming more intelligent, we've got more data going into that. But what we want to do with the model is actually automate all of this process behind the analysis. So what we want is that data to drive all of these components. So the data automatically working out what's the best algorithm to use to deliver the best prediction or the best forecast or the best decision. How do we then weight the various inputs into those particular algorithms to get an accurate decision? And also, how do we structure that algorithm? So should we be using maybe a very, very complicated neural network with thousands of hidden layers and hidden units, or should we look at a very simplistic model? We want the data to drive all of that. At the moment, there are some processes where a human is still coding up some of this structure. So we've got maybe computers that are creating the parameters of the algorithm, humans then working out which algorithms we should consider, but the human manually creating these hyperparameters. Where we're moving to into the future is automating the whole of this process in terms of the building of the models. But I think one common thing that we see people get really hung up on is, how do I build the most accurate model? What they then forget is, well, how do we then deploy that model so it then actually adds value? And what we see is lots of people spending lots of time and effort here. Then when a business wants to deploy that model, it then takes them equally as long to then deploy that, by which time the opportunity in the market has gone. So with regards to modelling, it's a case of how do we automate this process as much as possible and make it easy to move into a deployment environment. Move that model into maybe a batch decisioning process or real-time decisioning process, depending on the use case or the business problem that we're trying to solve. And then finally, what we're again moving into is human-like intelligence. So where we're trying to create more human-like interactions, which is all about reasoning on input and then explaining on output. So creating systems that allow us to ask questions of the system, and automatically a result that then comes back that answers that specific question. What we see in a number of organisations, they would ask a specific question of maybe how many sales of a product, how many products have we sold in the last 3 weeks, the last 4 weeks, or the last 5 weeks. Traditionally, from a BI perspective, they would go and find a report that gives them the answer to that question. Where we're moving more into is developing systems that you would ask a specific question of the system can then contextualise that question, and automatically the result then gets fed back to the individual. The system will automatically know where the information is to answer that specific business question. So, and again, we can use that for traditional type reporting, but we can also use it for more predictive capability as well. So you could ask a question of, how many products am I going to sell tomorrow? How many products am I going to sell tomorrow in a particular area of the country? And again, the system will automatically come back with the answer, rather than a human having to maybe hack around, produce various number of reports. The system will automatically do that. And that's where we are now in terms of technology. We're able to build systems like that that are seen as weak AI applications. We're not developing systems at the moment that are thinking for themselves and adapting to the situation in place. So then, and that's really all I want to share in the sort of 15 minutes that I had. Has anyone got any questions or views on that?
So one of the thoughts a lot of data scientists come up with is, usually we like to look at the data first, ask a question, and use these machine learning concepts to answer that question, and then go through that process multiple times. Going by what you're saying, are you sort of suggesting, or are you confirming that the current view about whether you should be questioning the data, or should the data actually be telling you what you should be questioning?
So wait, you've got the sort of two sides to that. You can either ask the question of the data and the result that comes back. What we're also starting to develop is, let's say you've got a data source, yeah, and there's maybe 5 or 6 different data scientists accessing that data source and using their own different ways to interrogate that data source and generating insight of that. What we're doing as well is to take all of that insight and collate it all together. So when then data scientist 7 then looks at that data, rather than starting from a square one, what they're able to do is automatically see, well, what has been the insight that has already been delivered from that data science work that has already happened. So again, that kind of work we're doing at the moment.
Are you saying the more complex the model, the harder it is to actually be deployed usually?
Yes, in general, the more complicated the model that you've got, the more you have to think about how do you recode that to deploy and execute really, really quickly. So an example is you could have a very, very sophisticated neural network that gives you a very, very accurate result. But what that neural network is doing is maybe trying to predict whether or not a transaction is fraudulent. Well, you need that neural network to run in less than a quarter of a second to make a decision of whether or not that transaction is fraudulent. So what you need is that balance of an accurate model, but one that can then get deployed really, really quickly and really, really easily and executed really quickly. And where SAS as a technology company is about is building a framework for data scientists to build the most complicated model that they have, but then deploy it into an environment in a very efficient way without you having to go through a whole recoding exercise to execute that model really, really quickly.
So you would say that really the trick is to make a model as simple as you can get away with.
To deliver the most accurate result. Yeah, because that's what you're trying to do in any type of analysis.
And just to extend that a bit more, when we get to more complex AIs, I'm guessing the problem we're going to have, whether they're self-driving cars or humanoid robots operating in an old people's home, will be that they might be great technology, but they will be very, very difficult to actually deploy. But in terms of where we're moving into the future, and as a segue into Noah's work, what we will start to see is those self-driving cars starting to adapt based on your individual behaviour. So the machines start to adapt to how you actually drive the car, with the algorithm actually being built based on your characteristics as an individual, rather than and that is the true self-learning. So where do you go? Where would be where do you regularly go? Where's the most efficient way? And developing based on how you interact with that car, rather than how the overall population wants to interact with the car. But obviously from a legal point of view, it's not you driving the car, so if something goes wrong, there's no one to sue.
And that opens a whole massive debate in the whole area of machines and the decisions that are being made. And again, with those algorithms, the very sophisticated algorithms, the inputs, we know what the inputs are, we know what the outputs are, but actually how that decision's being made is very much black box. So again, there's certain use cases that those very sophisticated black box algorithms can't be useful, because we can't go into that world of, I made this decision because the computer said so. Just because the computer said so doesn't mean that was the right decision to make at that specific time.
And we're going into causation.
So I know there was some other question.
Intervention. Apologies, intervention, but to keep on track, there's time for more questions as we go, but I think
No problem.
we'll go to the next speaker. Thank you.